In this example, we'll solve the initial value problem, y double prime plus 3y prime minus 18y equals e to the negative 2t, with y of 0 equals 3 and y prime of 0 equals 5. As with other initial value problems, we'll start by finding the general solution to the differential equation. Since this is a non-homogeneous differential equation, we'll start that process by finding the general solution to the associated homogeneous differential equation, which is y double prime plus 3y prime minus 18y equals 0. By looking at the characteristic equation and factoring it, 0 equals r squared plus 3r minus 18, which factors as r minus 6 times r plus 3, we can get the roots to be r1 equals 6 and r2 equals negative 3. And this gives us the general solution to the homogeneous differential equation, which is y sub h, our general solution, is equal to c1 e to the 6t plus c2 e to the negative 3t, where c1 and c2 are constants. Now, to find the general solution to the non-homogeneous differential equation that we started with, we next need to find the particular solution to that non-homogeneous differential equation. Based on our right-hand side, e to the negative 2t, our particular solution will have the form y sub p equals a constant a times e to the negative 2t. Using this, we get that the first derivative, y sub p prime, is negative 2a e to the negative 2t, and the second derivative, y sub p double prime, is 4a e to the negative 2t. In inputting this into our differential equation, we can solve for a. We get 4a e to the negative 2t, which is y sub p double prime, plus 3 times y sub p prime, which is 3 times negative 2a e to the negative 2t, minus 18 times y, which is a e to the negative 2t. And this all must be equal to the right-hand side of our differential equation, which is e to the negative 2t. If we look at our coefficient of e to the negative 2t on both sides, on the left we'll have 4a minus 3 times 2a, so 4a minus 6a, minus 18a, which will be negative 20a as the coefficient of e to the negative 2t on the left. While on the right-hand side, our coefficient of e to the negative 2t is just 1. So this gives us the algebraic equation, negative 20a is equal to 1, and thus a is negative 1 over 20. So we found that y sub p equal to a e to the negative 2t, which we now know is negative 1 over 20 e to the negative 2t, is a particular solution to the non-homogeneous differential equation. And using this with the general solution of the associated homogeneous differential equation, we can conclude that the general solution of the non-homogeneous differential equation is y of t equals negative 1 over 20 e to the negative 2t, our particular solution, plus c1 e to the 6t plus c2 e to the negative 3t, our general solution of the homogeneous differential equation. So we've now found the general solution of our original differential equation. To solve the initial value problem, we need to impose our initial conditions, y of 0 equals 3 and y prime of 0 equals 5, and solve for c1 and c2. If you'd like to see the steps of this done out, you can click the link to the right. Imposing these conditions gives that c1 is 67 over 45 and c2 is 281 over 180. Putting these back into our general solution gives us the solution to the initial value problem, which is y of t equals negative 1 over 20 e to the negative 2t, plus c1, 67 over 45 e to the 6t, plus c2, 281 over 180 e to the negative 3t.